Hi students, again this is another set of problems. This problem here and this one are very important. So we have this video, second video, then we're going to go after this video next week by the last chapter we need to explain, which is the random variable. So let us do these problems. An urn contains 5 identical balls, 2 white and 3 black. Okay, we have 2 white and 3 black. We draw randomly 2 balls from the urn. Calculate the probability of drawing 2 white balls. So it's a combination. 2 white, 2 out of 2 over 2 out of 5. 2 balls of the same color, 2 out of 2 or plus 2 out of 3 over total 2 out of 5. In this part, we draw accordingly to the following strategies. So here we have 2 white and 3 black. Let us see the strategy. We draw the first ball from the urn. We notice its color. We then replace it back, we return it back to the urn, and we add another ball having the same color of the drawn ball. So if you're going to draw the first times, it means white. You're going to return it back in the second draw. What you're going to get at the end, in this case, 3 white and 3 black. And if you draw a black in the first draw, B1, so you're going to return it back and you're going to add 1 black. So in this case, you're going to get 2 white and 4 black. Okay, this is the first draw, then you're going to draw. We do not draw, we then draw another ball. So then we're going to draw from after adding another ball. W1 getting a white ball in the first, B1 getting a black ball in the second. So W2 getting a white ball in the second draw. Calculate P of W2 knowing W1. So I know W1. What does it mean? I know in the first draw I have a white one. So I want to probability of drawing another white in the second draw. W2 is the second draw. I know the first draw is white. So I have now for the second draw 3 white and 3 black. What is the probability of drawing 1 white? So 1 out of 3 over 1 out of 6. Probability of W2 knowing B1, so I know I have B1, so it will be, I have now 2 white and 4 black, so white, it will be 1 out of 2 over 1 out of 6. I want you to realize one thing, guys, here. Look at the knowing. In the knowing, I have W1, and here, B1. I'm going to ask you, do we have another condition than these? Either in the first row you have W1 or B1. So here they form, because this is 100% and nothing in common. So we have a total probability. So if you want to find P of W2, we do total probability P of W2 intersecting W1 plus P of W2 intersecting B1, right? So P of W2 is P of W2, because total probability knowing B1, I don't have other condition, intersecting W1 plus P of W2 intersecting B1. And we know P of W2 intersecting the W1 is P of W. I want W2 with W1, so here P of W2 knowing W1 times P of knowing B1 plus P of W2 knowing B1 times P of B1. Here we already I have it up. We calculate it's 1 over 10. P of W1, what is the probability in the first draw to get a white? So it's 1 out of 2 over 1 out of 5 plus W2 knowing B1, we have it, we calculate it up 0.4, 2 over 6, which is, you can check the calculate, oh sorry, 2 over 3, that's it here. W2 knowing W1, you can check if I have something wrong, so this must be 1 over 3, I think. You can check it in the calculator. So times P of B1, to get a black in the first one is 1 out of 3 over 1 out of 5, and you can get it. Before I continue, I want to tell you something, guys. Anytime you have P, for example, of an event D, I know this event is F, and you have another one in the same problem, P of D knowing F bar. You have the answer of these. You know that F and F bar makes everything. So if I want to tell you to use P of D, since F and F bar is the whole universe and nothing in common, it will be a total probability. You do P of D like we did here, intersecting F plus P of D intersecting F bar, and then we do all of these. Okay? Here another problem. In school, 60% of the students play football. Among the students who play football, 30% playing tennis. I have football, tennis knowing football is 0.3. So the complement of it, what do you do for the complement? You do T bar. So the complement of it, let me here, I want to erase. If you want to find the complement of it, what will be the complement? P of T bar knowing F, the complement of this one will be 0.7. Among the students who do not play football, 55 play tennis. The students who doesn't play football, if they play football is 0.6. Not playing football, P of F bar. Write everything, guys. Is 0.4. Among these that play tennis is 0.55. If you want to find the complement of it, you put T bar F bar is 1 minus 0.55. Before I continue, here I have knowing F, you can see it, and knowing F bar. This is a total probability. So if they want me to use P of T, I do P of T intersecting F plus P of T intersecting F bar. So here I can do a tree table because it's a total probability. So I do P of F bar. Because I have used the application of the the application we're using in math, the graphing. So I don't have complement, so I'm going to write the complement as that form. Okay, so this is the complement. When you see it, it means complement. So P of F bar will be 0.4. Okay, and I know that P of T knowing F is 0.3, the complement will be 0.7. I know that P of T knowing F bar, this is knowing F bar, is 0.55. The complement will be P of T bar knowing F bar is 0.45. You know the tree table, you multiply these two and you put the intersection. If they want me to deduce P of T, so P of T will be this one with that one. Don't forget that the sum of all of this is 1. Okay. First of all, calculate P of F 0.6. P of T knowing F, we have it 0.3 given. P of T knowing F bar is 0.55. Calculate the probability that the chosen student play tennis and football. Tennis and football is 0.18. Then the probability that the chosen student play tennis but does not play football. Tennis, not football, this is 0.42. Deduce P of T, you make the sum of these two as you can see. The chosen student does not play tennis, knowing T bar. Calculate the probability he plays football. We did this before. It's the inverse of what? Of T bar knowing F. So we must use this one. So it will be P of F intersecting T bar over P of T bar. F intersecting T bar is 0.42 as you can see it here. If P of T is 0.18, the T bar P of T is 0.4. The T bar, it will be the complement 1 minus 0.4, which is 0.6, and you have the answer. Sorry, I forgot the name of the application that I have used in the programming. Okay, the GeoGebra. Because I have used the GeoGebra, in the GeoGebra you don't have complement, so I have put it this form. A doorkeeper carries 5 keys, of which 3 only open a door. So 3 open and 2 open bar. It doesn't open. Sorry, 3 open and 2 open bar. Only 3 open the he wanted to test them all, trying one after the other. One after that, it means I have an arrangement. Order is important. Note that the choice of keys is done randomly and without replacement, so arrangement and order is important. We call the key number n the key used in the nth draw. We call d1 in the first draw because n in the number of draw. Key number 1 does not open the door. P of d1 order important, as we said. It doesn't open, so I have 1 out of 2 over 1 out of 5. So 2 over 5. We call D2 the event key number 2 does not open the door. Calculate P of D2 knowing D1. I know that key 1 didn't open the door. Because key 1, I know that D1 did not open. So now what do I have for the second one? 3 open and 1 not open. What is the probability to pick another one which doesn't open the door? It will be 1 out of 1 over 1 out of 4, which is 0.25. Okay? Then deduce P D1 D2. I have intersection, so I look for knowing where you have D2 and D1. We have it here. So P of D1 intersecting D2, it will be P of D2 knowing D1 times P of knowing, which is D1. I have D2 knowing D1, and I have P of D1, which is 0.1. What is the probability of the event E? Key number 1 and 2 open and the door, and key 3 does not open. So as you can see, order is important. I want the first 2 to open, so it will be 2 out of 3 arrangement, and the last one will not open, 1 out of 2, because I have 2 not open over 3 out of 5. An air contains 6 identical balls, 3 black, 2 green, and 1 white. Here the given. A player draws 1 ball from the air. I want to draw 1. If the ball drawn is white, he wins 3 points. So white is going to get 3 points. If the drawn ball is green, he wins 2 points. If the ball drawn is black, he replaces back and drawn, he will put it back, so I have the same combination, and he draws another one. If the second ball is white, so here order is P of independent. This draw first, then comes the second one. Okay, if it is white, he wins 1 point. I'm going to draw this table. If it's green, he loses 1 point, and if it is in the second time black, he loses 2 points, minus 2. Calculate the probability of the following events. If the player wins 2 points. To win 2 points, so he must draw in the first draw a green. A green is 1 out of 2 over 1 out of 6, 1 over 3. He wins 1 point. 1 point he must draw. It's independent. I have to draw one after the other. Why it's independent? I know that the first one must be black. He's going to return back the black, and he's going to draw another one. So to get a white one does not depend on the black in the second draw, because I'm going to return it back to the urn. And so I do P of black in the first time, then P of white in the second draw. P of black in the first one, you have how many black we have? We have 1 out of 3 over 1 out of 6 times. Then I want to draw another white. It's 1 out of 1 over 1 out of 6, so 1 over 12. Then C, the player loses 1 point. So loses 1 point. So black in the first draw, then green. So here you can put draw 1, knowing draw 1, here knowing draw 2, doesn't matter. Black, so I have 1 out of 3 over 1 out of 6, then another one green, 1 out of 2 over 1 out of 6, and the last one loses 2 points. So first of the twice black, so 1 out of 3, 1 out of 6 times 1 out of 3 over 1 out of 6. An air contains 3 black balls and 1 white. We throw a fair coin. Okay, first we're going to start by a fair coin. If a head is show up, we add a white. So I have a 3 black and 2 white. If a tail, we add a black. So I have 4 black and 1 white. So first of all, we're going to throw a coin, and depend on the coin, what do you add? We draw at random and simultaneously 3 balls from there. So we're going to throw the coin, and then we're going to draw 3 balls simultaneously. So it's a combination the second time. Consider the two events. E note, the 3 drawn balls are black. A head show up. Calculate P of B, P of E knowing B, P of E knowing B bar. So here B and B bar form a total probability. So you can do a tree table, but no need. So they want, first of all, because if they want P of E naught, you do P of E naught intersecting B plus P of E naught intersecting B bar. Why? Because I have knowing B bar, and B. Always when you have, as we said in the first problem, B and B bar, it means knowing total probability. P of B, what does it mean, P of B? A head shows up, it's a 50%, you all know. A tail show up, 50%. P of E knowing B, so knowing B, it means I know a head. So what is the probability of drawing 3 black? I want to draw 3. So it's 3 out of 3 over 3 out of 5. And P of E knowing B bar, what does it mean knowing B bar? I know that a head shows up. What the probability of drawing also 3 black? It's 3 out of 4 over 3 out of 5, 0.4. Deduce P of E naught, the 3 drawn are black, so you do the total probability as we said. So P of E knowing B times P of B plus P of E knowing B bar times P of B bar. I have everything. E knowing B, we did it 0.1. P of getting a head is half. Here you have it, we did it up. P of B bar getting a tail is 0.5, you have the answer. Now we define the event E1 as one and only one white ball is drawn from the 3 drawn balls. So you have P1 one white and 2 black. So calculate 2 black. Calculate P of E1. No need to tell you find P of, for example, first of all B. Oh, okay, we know P of B. Find P of E1 knowing B, then P of E1 knowing B bar, then deduce P of E1. So directly you find by yourself P of E1 knowing B. I want knowing that a head, but I want to draw here what? 3 balls such that 1 white or 2 black. So I have 1 out of 2 times 2 out of 3 over total, 3 out of 5 in the first one. Here, knowing tail, I want 1 white, 1 out of 1, as you can see, 2 out of 4 over 3 out of 5. And because this is a total probability B and B bar, you do like we did here. Here times half, the same number times half, here times half, you get the answer. Number 6, in a factory, 3 machine XYZ, machine 20%, machine 30%, another one 50. You can see 20 plus 30 plus 50 form a total probability. Knowing from machine A we have 50% defect. You know the tree table. This is the complement in a D bar. I have put it like this because of the GeoGebra. D knowing Y, here you have 4%. The complement here, D bar knowing Y. The third company, the third machine, only 5% D bar. You do the product to get the intersection. If you want to deduce P of D, you make this one plus this one plus this one. So here defective produced by X, so it's 0.1. Directly you can write it if you have the tree table, or you do it step by step if you don't want to do the tree table. Of choosing a defective, you do because X, Y, Z form a total probability, you add these 3. This is very simple now. Now they want just the opposite. If you can read it, I want P of Y knowing D. I have P of D knowing Y. So directly it's a repetition of problems. So I do P of D intersecting Y over P of D. D intersecting Y, you have it here over P of D. Already we calculate it and you get the answer. Number 7, an urn contains 9 balls, 3 white numbered 1, 2, 3, 3 black number 1, 2, 3, 3 red number 1, 2, 3. We draw at random and in order 2 balls from the urn. Okay, you have this. Calculate the probability, the following probability of the 2 drawn balls had hold an odd number. So here, how many odd number I have? I have W1 and W3. Same, I have B1, B3. Same, I have red 1, red 3. I want 2 out of these. So how many balls I have? I have 6. I want 2. So it's 2. It's 2 out of 6 over total. I have 3, 3, 3, 9. 2 balls having the same color, or 2 are white, 2 out of 3, or 2 are black, 2 plus 2 out of 3, or 2 are red, 2 out. I want B. Yes, true. So 2 out of 3 plus 2 over total. I have 1 over 4. P of A intersecting B. What does it mean intersecting B? I want it same color and odd. So either I want to pick these two, or these two, or these two. No other alternative. So here I have 2 out of 2, 2 white and odd number, or 2 of that sort plus 2 out of 2, or 2 out of 2 over total, which is 1 over 12. I want P of A knowing B, so I have P of A intersecting B. We know that P of A knowing B is P of A intersecting B over over. So P of A knowing B is P of A intersecting B over P of knowing B. So I have P of B and P of A intersecting B. I can get the answer. Calculate P of C. The 2 drawn balls have different colors, so either one white, one black. So 1 out of 3, 1 out of 3 over total, or 1 white, 1 red, or 1 black and 1 red. So that's why instead of making plus plus, so I multiply it by 3. Prove that P of D. What is P of D? The 2 drawn have different colors and hold odd numbers. So they have different colors and hold odd numbers. So it means either I pick, for example, white 1 with B1, or white 1 with B3, okay? Or if you want to add, if you want to do it this form, you can do it by counting, for example. So I want one from these and one from this. If you don't want to do it this way, let us forget. I want from W1 the W3. I have B1, B3. Let me read the 2 balls have different they have different colors and hold odd numbers. So what are the choices that I can have? Yani suppose I want to pick from the white, I need to pick one from the white. How many choices in the white I have? I have 2 choices, so I pick 1 out of 2. And one from the black, I have 2 choices in the black to have odd numbers. One odd from white, one odd for a black. So I have 1 out of 2 times 1 out of 2 plus 1 out of 2 from here, 1 out of 2 from here, plus 1 out of 2 from here, 1 out of 2 from here. So instead of doing it, I can multiply it by 3. So this part is confusing a little bit because at the beginning I was confused to find the way. Now the 2 drawn balls have the same color. Have the same color. Have different color. This is they have different color. So I know, knowing C, what is the probability that they hold odd the numbers? Hold odd numbers, it means A. So I want P of A knowing C. You know that it's formula P of A intersecting C over P of C. So now, what is A intersecting C? The 2 balls hold an odd number and C have different color. If you combine it together, odd number and different color, this is nothing else than P of D over P of C, which is 4 over 9. You can realize that this problem is somehow confusing in some of its part. Number 8. An urn contains 6 identical balls, 4 green and 2 yellow. We draw at random and simultaneously 2 balls from the urn. We want to draw 2. We denote by A, B, C the following events. The 2 drawn balls are yellow. B, the 2 drawn balls have different colors, and the 2 drawn balls are green. So either 2 yellow or 2 are green or 2 have different colors. So this makes a total probability, as you can see, either it's A or B or C. So if they're going to give you an event, we can find it. Do, for example, calculate P of D knowing A, P of D knowing. I didn't know until now because I didn't continue the problem. Deduce P of D is P of D intersecting A plus P of D intersecting B plus P of D intersecting C, because A, B, C, these are all choices, nothing in common, and they form the whole universe. First of all, calculate P of A. The 2 drawn balls are yellow, so 2 out of 2 over 2 out of 6. The 2 drawn balls have different color, in one green and one yellow. The 2 drawn balls are green. Okay, 2 out of 4 over 2 out of C. They're going to give us another event. The 2 drawn balls are not placed back in the urn, so we're going to keep it with us. We draw again 2 balls from the urn and we designate by D the event, a green ball and a yellow. So I want to pick in the first draw the 2 balls, then I want to keep it with me, then I'm going to draw another ball. Let D be another 2 balls. Let D be the event, a green and a yellow we're going to pick. Find P of D knowing A. What does it mean, P of D knowing A? Knowing A, I mean, I know that the 2 are yellow. Because 2 are yellow, so I have only 4 green. To draw 1 green and 1 yellow, so I don't have yellow to draw anymore, so it's 0. P of D knowing B, I know B, I have different colors. So instead of having, because I'm going to keep the balls with me, instead of having 4 green, 2 yellow, now I have 3 green and 1 yellow. I want to have different color in the second time. So 1 out of 3 over 1 out of 1 over 1 out of 2 out of 4. So it's 0.5. And knowing the 2 are green, knowing C, so I know that the 2 are, knowing C, the 2 are green. So I have now 2 green and 2 yellow. I want to draw now 1 green and 1 yellow. It's 1 out of 1. 1 out of 2 times 1 out of 2 over 2 out of 4. Certainly now they're going to ask us at the end P of D. But before doing P of D, they told us, no, find these two, so that to tell us you must do total probability. P of D intersecting A is P of D knowing A times P of A, which is 0. P of D intersecting B is P of D knowing B times P of B. P of D intersecting C is P of D knowing C times P of C. And deduce P of D, you make the sum of all of these that you have here, and you have the answer. Okay, now we're going to continue. A dartboard has 3 pies, 1, 2, 3. 2 players A and B throw a dart to the target. So I have pies, 3 pies, 1, 2, and 3. So I have 1, 2, and you're going to hit, guys, a pie. You have 3 pies. You're going to throw a dart. Each dart throw hits one and only one pie of the dartboard, and the throws are independent. You know, the second throw, it does not independent. If you're going to throw whatever you're going to throw, flip a coin, flip or throw a dice, sorry, or throw a dart. So actually, it's not dependent; it's independent, because the second row or the third row, it does not affected by the draws before. For player A, the probability of hitting one, for player A, I'm talking about player A. So dart one, knowing what player hitting the first one, P of 1 knowing A, I have it written here, 1 over 12, of hitting player A to hit pi 2 is 1 over 3, player 2 hitting 2 knowing player A 1 over 3, hitting 3 knowing A is 7 over 12. Okay, however, for player B, the 3 equivalents are equiprobable. What does it mean, equiprobable? They are the same. P of 1 knowing B equal P of 2 knowing B. B is the second player, hitting pi 1, pi 2, pi 3 is 1 over 3. 1 over 3 plus 1 over here plus 1 over 3, it's equal to 1, and all are equiprobable, they are equal. We're going to start by part A. Player A throw the arrows 3 times. We said it's independent, don't forget. We designate by EFG the following events. We have them. Find the probability of event E. What's event E? Player A hits the pi 3 times. So it's independent. So we're going to say, so it's P of E is, they're going to hit the first player pi 3. This is the first player pi 3. So because it's independent, you're going to say it's P1 of A times P1 of A second time, and the third time P1 of A. Independent, don't forget, each hit alone. I want that this player hit pi 3. Sorry, pi 3, player A. Sorry, it's not 1, it means he's going to hit pi 1. I want pi 3, so I need to use this one. Player A is A. 3 knowing A 3 times. I write it again 3 times because it's independent. And I write it a third time, so it's 7 over 12 power 3. After player A hits the 3 pi's 1, 2, 3 in this order. You know what I told you, that when you want to use independent, which is P list, the order is important. If you put P1 knowing A times P2 knowing A times P3 knowing A, it means that he's going to hit pi 1 in the first, then pi 2 in the second, pi 2, then pi 3. So I do this order. So it's independent, 1 over 12 times 1 over 3 times 7 over 12. Then he's going to hit it in order. So either you have 1, 2, 3, or 1, 3, 2, or 2, 1, 3, 2, 3, 1, and the last one 3, 1, 2, or 3, 2, 1. So how many choices I have? 6. So 6 times this one. Okay. Part B, we choose at random one of the two players. The probability of choosing A is as twice as the probability of choosing B. So what did they say? They said here that P of A is twice P of B. And you know, guys, that either you're going to choose A or B. So it means P of A plus P of B is 100%. Because either you're going to choose player A, or player B. So if P of A plus P of B is 1, and P of A is double P of B, so if you put here instead of A 2P of B plus P of B, so P of B will be 1 over 3. Okay? And P of A will be 2 over 3. Okay? What the probability of choosing A? So choosing A is 2 over 3 and B is 1 over 3. One throw is carried out. Because knowing here you have, guys, listen. Since if you have knowing A and knowing B, this makes a total probability, because either, for example, suppose what the probability that pi 1 is hit. So either I'm going to pick 1 knowing A, P, times P of 1 knowing B, because A and B form a total probability, either A or B, and this is the whole universe. You do it at the total probability. Let us see. One throw was carried out and part 3 was hit. What's the probability that player A was chosen to throw the arrow? Before I have part B. One throw is carried out only. What the probability that pi 3 is hit? This pi 3 can be hit either the pi 3 from player A or from player B, as I told you, because A and B form a total probability. So it's a P of 3 knowing A times P of A plus P of 3 knowing B times P of B. P of 3 knowing A, we have it, it's already given. P of A, the probability of P of A is 2 over 3. P of 3 knowing B, it's equiprobable 1 over 3 times P of B is 1 over 3. You have the answer. One throw was carried out and pi 3 was hit, knowing 3. What the probability that player A? So it's P of A intersecting 3. P of A intersecting 3, we have it here, we did it. So it will be P of 3 knowing A times P of A over P of 3, and P of 3 we have the answer. So everything is done. So guys, this is the end of these problems. This is another quick revision of problems. So on Monday, you're going to have another homework. It will be online. Then we're going to have a reflection on the Padlet about it. I'm going to put some question and you're going to reflect. And the next week, we're going to do the last part of the probability and the last chapter for this year, which is random variable, which is very simple. I hope that everything is clear, you're understanding all the problems, and hope to see you soon, because really I have missed all of you. Yalla, take care and stay safe.